So let's start with the trig antiderivative rules and remind ourselves about the ones that we know so far, and then we're going to learn 2 additional rules. So we'll end up with antiderivative rules for all 6 of our trig functions. So remember, we know what the antiderivatives of sine and cosine are. So we know that the antiderivative of sine is negative cosine. We can always check our antiderivative rules by taking the derivative. We know that the derivative of cosine is negative sine, so I'd have negative sine, which would give me back sine. The antiderivative of cosine is sine, since the derivative of sine is cosine. Okay. So we've known those 2 rules for a little while, but we're also familiar with the rules for the integrals of tangent and cotangent. So let's just remind ourselves what those rules are. So integral of tangent and also the integral of cotangent. Now, in case you've forgotten each of these rules, we can derive what those antiderivative rules are using u substitution. So notice that the integral of tangent can be written as the integral of sine over cosine. And if we use u substitution here, we could let u be equal to cosine x, so that du would be negative sine x dx. Okay, so we could rewrite this as negative du over u, and see that that would be negative the absolute value, negative log of the absolute value of u plus c, or negative log of the absolute value of cosine x plus c. Okay, notice that using my log rules, if I wrote this as log cosine x to the negative 1 power, remember with log rules, if I have a log x, that can be written, let's see, let me write it as a log b. This can be written as log of b to the a power. So if we take that negative 1 and raise cosine x to the negative 1, that's the reciprocal of cosine. So we could also write this as log of the absolute value of secant plus c. Okay, so now we have this rule, or reminding ourselves of that rule. You can either remember it as negative log the absolute value of cosine, or log the absolute value of secant. Okay, so if you weren't as familiar with that rule, now you have a way to help you remember what that rule is. For cotangent, we could go through a similar procedure to rederive the rule, but the integral of cotangent will be log of the absolute value of sine x plus c. Okay, whoops. So we have those rules. So that's 4 of our 6 different trig functions. So what are the other trig functions that we need rules for? Well, we need rules for the integral of secant and the integral of cosecant. Okay, so let's look at how we can figure out the rule for first the integral of secant. So there's a little algebraic trick to derive the rule. You won't have to remember this trick. I'm just going to show you where the rule comes from, and then you can memorize the rule. So the trick here is to take our secant x and multiply by secant x plus tan x over secant x plus tan x. We're trying to introduce some other pieces into this integral so that we can make use of u substitution to help us solve the integral. And this is a common technique in math, to multiply by something that's essentially 1, but add some extra pieces that you need to help you solve the problem. So I'm multiplying by the secant x plus tan x over itself, and then we're going to let u be equal to secant x plus tan x, so we can find what du is. So remember that the derivative of secant x is secant x tan x, and the derivative of tan x is secant squared x. So we get all that dx. Now notice I could pull secant x out of this, so I'd have secant x times tan x plus secant x, okay, which is exactly what we're seeing in our integral here. So this numerator of secant x times secant x plus tan x dx is going to become du, and then that denominator here of secant x plus tan x becomes u. So we see we get log of the absolute value of u, or log of secant x plus tan x plus c. Okay, so now you can see where that rule comes from for the integral of secant x. So we've got the integral of secant x dx is log secant x plus tan x plus c. Okay, and with a similar kind of trick, we can find that the integral of cosecant x is log cosecant x minus cotangent x plus c. You may also see the rule for the integral of cosecant x written as negative log of cosecant x plus cotangent x plus c. So you can remember either one of those different forms. To show that these two are equal requires a bit of algebra and things. It's not just as simple as the negative sign on the outside becoming the negative sign on the inside. There's several steps there. But both of those would be equal to each other and would be the antiderivative for cosecant x.